There are two types of electricity: static and current electricity. Static electricity is electricity that doesn't move. Current electricity flows in a circuit or a path. So it moves from one point to the other. Static is what you think with the Van de Graaff generator. The charges, or these negative charges, build up usually through friction, is what causes static electricity. The Van de Graaff has a belt that spins around, and as it rubs against the bottom and the top of the Van de Graaff, it creates friction. And the electrons rub off on this ball and spread outward on your body because they want to get as far away from each other as they can, and you provide a larger surface than that little ball does. And so they can get farther away from each other. And they get out on your hair, and since they don't like each other, they spread outwards and your hair moves apart. And it'll stay like that until you discharge it. You step down off of the little platform that we used, and at that point they can float off your body back down to the earth, which is a even bigger object. We can get even farther away from each other, and that's called the discharge. Oftentimes you'll get shocked during that point as it tries to jump from one object to another to make it back down to the earth. This is what's known as providing a ground to the electricity. It wants to flow back down to the ground, back down to the earth, and get as far away from each other as they can. So that's static electricity. Current electricity flows in a path, runs from the negative side around the circuit and back to the positive side. It wants to go from one side of the battery to the other side. In doing so, it has to be a closed circuit, meaning there has to be a path all the way around. Like this switch here has to be closed for it to pass through. If you were to open this up, that would be known as an open circuit, and the energy would not pass through it. So not only can you use a switch to open a circuit, but if you were to just cut the wire, that would be known as an open circuit as well. So we have open and closed circuits. We also have parallel and series circuits. This is a series circuit here where there's one path it can go through to travel around to get from one end of the battery to the other. Here with parallel, there are multiple paths for it to get from one side of the battery to the other. Even if I was to cut off one of these paths, say if I was to eliminate this light bulb here, the electrons could still make its way from one side to the other without having to go through this path over here. So by removing a light bulb or cutting a wire on a parallel circuit, the others will still work. Not so with a series circuit. With a series circuit, if one of the light bulb goes out, as the electrons pass through, they run into the side of the light bulb here, run outward through a little bitty wire, and when you run the electrons through that very small filament wire, it heats up and glows, and that's what gives off the light, and then comes back down to the bottom of the light bulb, and then runs out and hits the side contact on the next light bulb, runs up through it, across it, back down to the bottom of the light bulb, and then continues its path. If you were to burn out this light bulb, if it broke, it'd be essentially like cutting the wire. And so the electrons couldn't make it through to the other side as well.